Hello everyone, this is Mr. Zimmerman, and today we're going to learn about section 7-4. The theorems in section 7-4 really come as a direct result of the similarity properties from triangles that you learned about in section 7-3. I tend to think of these as kind of some shortcuts where you could have possibly drawn two separate triangles. You can use these shortcuts to get the answer a lot quicker. Let's take a look at the two theorems in the box at the top of the page. The first theorem is the triangle proportionality theorem. It says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. Well, that's a lot of words. I think if you just look at the picture and then I'll write down what's true here for you, I think you'll see it a lot easier. So in this one, for this first picture here, this first diagram right here, what we're going to write down is that the length of segment RT over the length of segment TQ is equal to the length of segment RU divided by the length of segment US. So that's all you have for that one. That's what all those words say. Now there's also a note here that the converse is also true, which means if you can show that this proportion is true, that these two ratios or these two fractions are equal, then you can conclude that that segment inside the triangle is parallel to the third side. Just make sure if you're going to use this triangle proportionality theorem that you must know that this segment TU is parallel to this segment QS. Now we're going to extend that idea to get this corollary to the triangle proportionality theorem. And this one says if three parallel lines intersect two transversals, then they divide the transversals proportionally. Again, that's a lot of verbiage there, but let's just take a look at this picture and I'm going to write down what's true for you. But again, to use this, you have to have that these three lines are parallel. So they'll either need to give you a statement that they're parallel, that line R and line S and line T are parallel, or they'll have to put these little arrows on the diagram indicating that they're parallel. Then you can use the corollary. So this theorem is going to say the length of segment UW over the length of segment WY is going to equal the length of segment VX divided by the length of segment XZ. All right. If you want to apply these two theorems on the next test or quiz, well, this is I think the situation where a picture is worth 1,000 words, because you're going to want to look in your note packet at this drawing and this statement, this proportion right here, same thing here. You want to have this drawing that you refer to, and then you want to look at this proportion right here. Because to remember these two theorems in words is it's pretty difficult to do. Let's go ahead and use these theorems then in example 1. Example 1, part A, is it's pretty set up for you already. Not only did they give you the diagram, but then they took all the given information here and they also drew that on the diagram. You want to note that these two segments, segment BE and segment CD, are parallel. So then we can apply the theorem. And then let's just go ahead and set this one up. Now notice that we're trying to find the length of segment AE. So let's go ahead and we'll call the distance from A to E, we'll call that X right here. All right, so this one should set up pretty quickly. So what we have to do then is we have, using your triangle proportionality theorem, we have X over 9. That has to equal 8 over 12. You could reduce the 8 over 12, or you can just go ahead and solve the proportion. So I'm going to do this cross product, so that's going to give me 12 times X is 12X. And on the other side, I have 9 times 8, that is 72. And then I'm just going to divide both sides by 12. And I get X equal 6. And so the way we set it up is x is the distance from A to E. That's what we were trying to find. So we'll write this. And there's our answer for example 1, part A. Well, let's look at part B. In part B, everything is labeled on our diagram again. Again, you want to notice that this segment QS and this third side of the triangle PT there, those are parallel. So we have to find ST. So let's call the distance from S to T, we'll call that X again. And let's go ahead and set this one up. So this one, we're going to have 6 over X is equal to 4 over 10. Let's do our cross product. So our first cross product gives us 4 times X is 4X. And our other cross product is 6 times 10, which is 60. Then we just divide both sides by 4, and we get X equals 15. And again, X is the same thing as the distance from S to T, which is what we were trying to find. And there we go. In example 2, part A and B, we're going to use the converse of the triangle proportionality theorem. And again, what we want to do is we want to set up that proportion. And that if that proportion is true, if we have 2 equal ratios, then we can conclude that that segment, for example, in part A, that the segment PQ is parallel to the third side of the triangle LM. So let's set up our proportion. So in this one, let's go 16 over 18. That has to equal 24 over 27. If that's true, if those 2 ratios are equal, then we will know that segment PQ is parallel to segment. Well, I just noticed there's an error on this. It's on part A here. It says determine whether segment PQ is parallel to segment MN. That would be an error. This segment right here, we're going to scribble this out because this should say segment ML. So we need to decide if our proportion that we set up is true. Well, one way to do this is we could reduce these fractions. So we could divide on the first fraction, we could divide the numerator and denominator by 2, and we would get 8 over 9. And then in the second fraction, or the second ratio on the right-hand side, we could divide the numerator and denominator both by 3, and we would get 8 over 9. And we would see then that that is a true proportion. But then there's another way to do this, and I haven't really showed you this. We know that the cross product should be equal if we have a true proportion. So let's test it that way. That's just a different way to go. So what we can do is we can do this cross product. So we can do 16 times 27, and then we want to see whether or not that's equal to 18 times 24. So let's test it that way. Then we have 16 times 27, that's 432. And then on the right-hand side, we have 18 times 24, that's also 432. So then that checks. So this is a true proportion. So then if that's true, then we know that, yes, they're parallel. All right, so I guess our conclusion is, yes, that segment PQ is parallel to segment ML. All right, let's move on to part B. We're going to do the same thing. In part B, I'll set up the proportion. So I'm going to do 12 over 10. And I want to see if that's equal to 18 over 16. I'll check to see if this is a true proportion by using our cross products again on this one. So we're going to see if 12 times 16, we're going to see if that's equal to 10 times 18. On the left side, we have 12 times 16. Well, that's 192. And then on the right side, we have 10 times 18, that's 180. And we can see that those are not equal. Well, if those are not equal, then that proportion was not true. So then we're just going to say that these are not parallel. So I'm just going to write not parallel. Let's turn the page and go on to example 3. Example 3 uses the corollary to the triangle proportionality theorem. And there's some things that are given on this drawing that we have to look at. So I would say the first thing we want to look at is we should see that we have some alternate interior angles here that are congruent. So those two angles are congruent. Also here, these two angles are congruent. Well, again, if alternate interior angles are congruent, then the lines are parallel. So what they're trying to tell us here is that line L is parallel to line M, and then also line M is parallel to line N. So I drew these little arrowheads for you. The problem says in part A here to find the distance from D to E. So what we're after here is we're after the length of this segment right here. That's DE. So let's call the length of that green segment right there, let's call that X. Then the other segment lengths that we need here are 32 and 21 and 28. So let's set up our proportion for part A. So we're going to write X over 32. That would have to equal 21 over 28. Let's do our cross products. So we have X times 28, that is 28X. That will equal our other cross product of 32 times 21, which is 672. And then we'll just divide both sides by 28. And we have X equals 24. And again, if you look back at our diagram, we labeled the X as the distance from D to E, and that's what we're supposed to find. So we can write this as equal to the distance from D to E. And there we go, we have part A done. Let's do part B. In part B, we can see that we have these three corresponding 90-degree angles that are congruent. So the three lines would be parallel. So we'll just go ahead and set up our proportion. So for this one, we're going to write X over 51 equals 36 over 54. Let's do our cross product. So we have X times 54, which is 54X. And the other side, we have 51 times 36, which is 1,836. And we'll just divide both sides by 54. And we have X equals 34. And in this problem, all we had to do is find the value of X, which we did. So we're all set with this one. Now let's take a look at what's in this box in the middle of the page. We have this angle bisector theorem. This one says if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. Again, that's kind of wordy, so let me show you what's true on this one based on the diagram, and I think it'll make a lot more sense. First, we have to make sure that the if part, or the hypothesis of this theorem, is true, which says that we need an angle bisector here. So we can see right here that this angle at C is being bisected. So we got to make sure that's true first. So we have this angle is congruent to that angle. So once we have that, then I should be able to write down our true proportion and we'll be all set. So what all those words say in the conclusion of this theorem is just that the length of segment AD divided by the length of segment DB, that has to equal the length of segment CA divided by the length of segment CB. So again, this is a theorem that has a lot of words to it. So again, what you want in your notes for the next test or quiz is you want this picture along with this proportion right here. And then you should be able to match everything up and do the problems. So let's go on and do example 4. So here we go in example 4, part A. We're going to set up our proportion. So what we have in this one is we have x over x plus 2 is going to have to equal 8 over 12. Now let's set our cross products equal. So we're going to have 8 times the quantity x plus 2 is equal to 12 times x. Then let's go ahead and distribute on the left. That gives us 8x plus 16 equals 12x. Now let's subtract 8x on both sides. 8x's will cancel on the left, and now we have an equation that says 16 is equal to 12x's, take away 8x's, that's 4x's. Then we divide both sides by 4, and we get a solution of x equals 4. But we're not done on this one, because if you look back at the directions, it does not say to find x. We have to find the length of segment EF and the length of segment FG. So if you look at our diagram here, we can see that x is the same as the length of segment EF. So we could just write this is equal to EF. So we have that part done. But then we need to take our x equals 4, and we need to plug it into that x right there in order to get the length of segment FG. So the length of segment FG is equal to x plus 2, which is going to be 4 plus 2. So FG is going to equal 6. And there's the other part of our solution. Let's go on to part B. And let's set up our proportion. So in this one, we're going to write 16 over y plus 3. That has to equal 40 over 3y. Now let's do our cross products. So let's do this cross product first. So we've got 3y times 16. That's going to give me 48y. That has to equal my other cross product, which is going to be 40 times the quantity y plus 3. Let's go ahead and distribute on the right-hand side then. So we have 48y equals 40 times y is 40y, plus 40 times 3 is 120. Now let's subtract 40y on both sides. They cancel out on the right-hand side, and we got 48y's, take away 40y's. That'll leave me 8y's on the left-hand side and 120 on the right-hand side. And then divide both sides by 8. And we have y is equal to 15. But again, we're not done with this one. Because if you look back at what we were supposed to find, we're supposed to find the length of segment RV and the length of segment TV. So that means we got to take our y equals 15, and we're going to take our 15 and we're going to plug it in. We're going to take our 15 and we're going to plug it in for this y right here, and we're also going to plug it in for that y right there. We have the length of segment RV is equal to 3 times y, so that's going to be 3 times 15. So we get RV equals 45. And then for our other segment length, we need TV. And that one was y plus 3, so that's going to be 15 plus 3. So we get the length of segment TV is 18. All right, well, let's move on to part C. In part C, we just need to find the value of x, but there is one thing that we will need to label on our figure, and that is the length of this segment right here at the bottom of this small triangle. Well, it should make sense that if this entire bottom of this large triangle is 28 units, that if we subtract x from 28, x would be the bottom of this triangle on the right, then we should be left with the length of this segment that makes up the bottom of this small triangle. So I've labeled the bottom of this small triangle then as 28 minus x. Now the other thing I should be saying is in order to use this angle bisector theorem, we have to have an angle that's bisected. So we want to make note that, yes, right here, this angle is congruent to this angle. So we do have an angle bisector, so we can apply the theorem. So let's just go ahead and write our proportion. So we will write 28 minus x over x is equal to 8 over 24. Then let's do our cross product. So we have x times 8, that's 8x. That is going to equal 24 times the quantity, 28 minus x. Then we will distribute on the right-hand side, and we get 24 times 28. That is 672, and then distribute the 24 times the negative x, and we get minus 24x. Then let's add 24x on both sides. The 24x's will cancel on the right-hand side. On the left side, we have 8x's plus 24x's. That'll give us 32x's, and that will equal 672. Then we'll divide both sides by 32, and we'll have x equals 21. So we found x, and if we look back, you can see that we're supposed to find the value of x. So we've completed part C. So let's go on to the last one. Then let's set up our proportion for part D. So we have 4 over 5. That's going to have to equal x minus 1 over the quantity x plus 3. Now let's set up our cross products. So we have 4 times the quantity x plus 3. That has to equal 5 times the quantity x minus 1. Then distributing on the left-hand side, we have 4x plus 12. Then we'll distribute on the right-hand side, and we'll get 5x minus 5. Well, then let's subtract 4x on both sides. And we have 12 on the left-hand side now, and that will equal 5x, take away 4x. Well, that's 1x. And then we also bring down that minus 5. And then we add 5 on both sides, and we get 17 is equal to x. Again, we're not done on this one because in part D, we're supposed to find the length of segment NP and the length of segment LP. And then the other thing that I keep forgetting to point out on these is that before you can use this angle bisector theorem, you got to make sure you have an angle that's bisected. So it's kind of hard to see here, but I think you can see down here at angle P right here, that angle is bisected. We have this angle is the same as that angle. Anyway, to wrap this one up, we're just going to take our x value of 17 and plug it in for that x. And then we're also going to take our x value of 17 and we're going to plug it in for that x. So then we have the length of segment NP. That is equal to x minus 1. So we're going to plug in the 17. So we have 17 minus 1, which gives us 16. And then we need the length of segment LP. So the length of segment LP, that is going to be x, which is 17 plus 3, and that'll be 20. So then let me label both of these again. So 16 is the length of segment NP, and then 20 is the length of segment LP. And that wraps up section 7-4. All right, guys, thanks for watching, and I'll see you in class soon. Bye.